In this video, I'm going to show you how to use the power rule among other rules for differentiation or taking the derivative of a function. So let's start with a sample function f of x equals 2x cubed minus 3x squared plus 2x. Before we go ahead and take the derivative of this function, we need to review a couple rules. First is the power rule, which says that the derivative of x raised to a power is equal to n times x raised to n minus 1. So whatever n is, the derivative will have a power of n minus 1. Here's another useful trick or rule. It's if you have something, or if you're taking the derivative of a constant times a function, that's what this prime indicates, then all you really need to do is take the derivative of the function and just multiply by the constant. A third rule that's useful is that if you're taking the derivative of a sum of two functions, you can take the derivative of the first function and add it to the derivative of the second function. So we're just looking at addition in this case. So let's return to our original function f of x and let's try to take the derivative. Well, okay, so we have f prime of x equal to 2x cubed minus 3x squared plus 2x, and I just noticed I forgot to indicate that this whole entire expression is differentiated. So here is a prime. Now that makes sense. So what are we going to do? We're going to apply the derivative of a sum, so we can actually just take the derivative of all of these individual terms. So that's what's done in the second line in red, where each term is added just like in this rule, and the negative is in the parentheses. The parentheses are just used to group the different functions or expressions, however you'd like to look at it. All right, so the next step here is to use the rule in blue and to take out each constant. So first we take out 2, and then we take out negative 3, and then we take out 2, and now we just need to use the power rule for each of these expressions. Once we do that, we just bring down the constants as before, and this is the expression that's left. So this becomes 3x squared upon applying the power rule to take the derivative of x cubed. Then we take down the negative 3, and the derivative of this is 2x. According to the power rule, the exponent decreases by 1, so there is a imaginary 1 here, and the derivative of x is just 1. You can see that with the power rule because there is a 1 here, and using the power rule, 1 minus 1 is 0, x to the 0 is 1, and the original value of n is 1, and 1 times 1 is 1. So the power rule works for this case as well. So now all that's left is to do some algebraic simplification. We do 2 times 3 to get 6, negative 3 times 2 to get negative 6. Of course, the 2 remains, and so this is our final expression for the derivative for a given value of x.